In this video, we're going to be doing some practice problems that involve the segment addition postulate. And this postulate is on page 10 in your student journal. And basically all the segment addition postulate tells you is that if you have a line or a line segment, if point B is between points A and C, then the length of AB plus the length of BC must equal the length of the whole, the length of AC. I'll add some visual here so you can picture what's going on. The part plus the part, so these two pieces, AB plus BC, must equal the whole. And so we're going to be using this part plus part equals the whole as our segment addition postulate for the practice problems that we're about to do. So if you could please turn to page 11 in your student journal. We're going to start with numbers 4 through 6. In 4, 5, and 6, our job is to find the length of VW. And we're going to be using the segment addition postulate. In number 4, we have a line segment VU, and we know that its length is 31. And point W is in between V and U. And we know that WU has a length of 8. And so we're going to use this segment addition postulate to help us find the length of VW. Some of you might automatically know what to do, and that's fine, but I'm going to set up an equation using the segment addition postulate. We know that the part VW plus the part or the line segment WU must add up to equal the whole VU. And now I'm just going to go and substitute the lengths that I do know into my equation. I don't know the length of VW, so I'm just going to keep it. WU has a length of 8, and VU has a length of 31. So now I just need to solve this equation to find the length of VW. So I'm going to subtract 8 from both sides. And this might have been immediately what you did at the start. You might have just known right at the beginning to do 31 minus 8, which is fine. But I wanted to show you how to set it up using the segment addition postulate. And so when you solve this equation, you get that the length of VW is equal to 23 units long. In number 5, we're still trying to find the length of VW. This is another one where we know the length of one of the parts and we know the length of the whole. So this is going to be subtraction like it was last time. Again, I'm going to set it up as an equation so you can visualize the segment addition postulate. The part UV plus the line segment VW must equal the whole line segment UW. UV has a length of 6, and UW has a length of 18. I'm going to subtract 6 from both sides to get that the length of VW is 12 units long. In number 6, I'm trying to find the length of the whole line segment VW here. And this time I'm given the lengths of the parts. I know the length of WU is 45 and the length of UV is 30. So you might automatically know to add those. Again, I'm going to show you the equation. Line segment WU, its length added with the length of UV must equal the length of the whole line segment VW. WU has a length of 45, and line segment UV has a length of 30. And so the length of VW is 75 units long. And again, you might not have needed to set up each equation. As long as you're showing what math you're doing, that's fine. So if for your worker number 6, you put 45 plus 30 equals 75, that's fine as well. Number 7, a bookstore and a movie theater are 6 kilometers apart along the same street. A florist is located between the bookstore and the theater on the same street. The florist is 2.5 kilometers from the theater. How far is the florist from the bookstore? I'm going to draw a picture so we can visualize what's going on. So we have a bookstore. I'm going to label that with point B, and a movie theater. I'm going to label that with point M. And they're 6 kilometers apart. A florist is located between the bookstore and the theater on the same street. So we're going to act like this is the street. So the florist will be a point in between point B and M. And it's 2.5 kilometers from the theater. So I'm just going to label the florist with an F. And I know that this distance is 2.5 kilometers. So now you can see I've got a situation that looks very similar to numbers 4, 5, and 6 up above. And we're trying to find out how far the florist is from the bookstore. So I'm trying to figure out that length there. And again, you might automatically see that you have to subtract 2.5 from 6, but I'm going to set up the equation just so you can see. The length of BF, this distance, must add with the length of FM to equal the length of the whole, BM. FM is 2.5, and the length of BM is 6. So again, you would do 6 minus 2.5 to get that the distance from the florist to the bookstore is 3.5 kilometers. Now we're going to add an extra problem that's not in your book. And so I'm going to give you a second. Go to page 10 and find some empty space on page 10. And you don't have to write the entire problem, but I would definitely write down this part and the labeled picture that we're about to draw. So I'd pause the video and start by jotting down these links somewhere on page 10. So in this problem, it says point K is between J and L on segment JL. We're going to use the following information to write an equation in terms of X. Then we're going to solve the equation and find JK and JL. So first, let's draw a picture so we can see what's going on. It tells us that point K is in between point J and L. So I'm just going to draw a line segment, JL. And point K is just somewhere in between. I don't know exactly where it is. It could be somewhere towards the middle. It could be way over here. It could be way over here. It might not be drawn to scale, my picture. But I just got the situation set up. And I'm going to go in and I know some lengths. So I'm going to label those in my picture. The length of JK is 6x. The length of KL is 24. And the length of JL, I'm going to use the fancy little symbol here, that whole distance is 7x plus 6. So this is when writing equations using the segment addition postulate is useful, because now we have some variables in here, and so we need to set up an equation and solve it to find x. And so what we know we've got a line segment here with a point in between. So we know that the length of JK, this part, plus the length of KL must add up to equal the length of the larger line segment JL. Now I'm going to go in and take my lengths and substitute them into my equation. JK has a length of 6x, KL has a length of 24, and JL has a length of 7x plus 6. We need to solve for x, so we're just going to solve this equation. I'm going to move all my x's over here. I'm going to subtract 6x on both sides of my equation. Now I'm going to subtract 6 on both sides. And I get that x is equal to 18. It has a blank for me to fill that in. I'm going to fill that in over here. Notice now they also want me to find the length of JK and JL. So now I actually have to take my x value and substitute it in to find the lengths of these line segments. I'll do that work over here. I need to find the length of JK. I know that JK is equal to 6x, or 6 times x. And so when I substitute 18 in for x, I know that JK is equal to 6 times 18, or 108. JL is equal to 7x plus 6. So now that I know x, I can substitute 18 in for x. So JL is equal to 7 times 18 plus 6, which is 132.